Hello. Today I will be discussing Newton's second law, and I will use it to describe the mathematical relationship among the net force on a macroscopic object and its mass and acceleration. I will go over net force, the equation for Newton's second law, and also a few different examples just to reinforce these concepts. In order to understand Newton's second law, you first need to understand net force. Now, net force is the combination of all forces on an object, and it describes both the magnitude and the direction. So as you can see, force A plus B plus C plus D gives you the total net force. Now, in this clip, when the object has no forces pushing on it, or they are all equal and opposite, the net force will be 0, and the object will not move. But when there is a overall net force that is positive or negative, it will move in that direction. Now, using this knowledge, we can see that force can also be found by multiplying mass times acceleration. However, you can also rearrange it to find for acceleration or mass of an object by just taking force and dividing it by the other leftover term. And in this clip, I'm going to be tapping on the desk. And as you can probably hear, when there is a greater acceleration, there's a greater force, meaning a louder sound. Now, in this clip, I'm going to toss a stuffed dragon with both a small and a large force. And as you can start to begin to see, when the object has the same mass, but it is thrown with a greater force, there's a much greater acceleration and speed.